Hello, this is Alex Wood, and I am going to tell you about the repository pattern today, along with the unit of work pattern, and we'll be learning domain-driven design. This is going to take about 20 minutes or so of your time, so, just to let you know. So, we're going to go ahead and create a console application in Xamarin Studio with the MonoDevelop framework. So here we go. This will be a repository pattern example. Okay. Now we're going to go ahead and we're going to add a new folder. Now normally you would break these down into separate DLLs, but because of time and other constraints, I'm just going to go ahead and break it down into sizable pieces that I think that you can follow. Core, and I'll explain each of these parts. Domain. So in domain-driven design, I'm gonna, and again, normally these would all be different. These would all be different DLLs that would be imported. So, and they would, each of them would be in their own package. So infrastructure implements the domain. Okay, and we'll go ahead and add a new folder, and we'll call it business logic. This is domain-driven design. So in here, we're going to go ahead and add a new folder, and we'll call it repositories. And under domain, we're also going to go ahead and add a new folder, and we're going to call it units of work. And in the domain, you are also going to add a new folder for exceptions. So you would write all your exception classes in here as well. So this is basically going to contain only interfaces. So user repository. All right. And this is an interface. And we're going to create we're also going to create a generic repository. Generic repository. And basically, this is also an interface. And this is an interface. And this was going to be of type E. So it's going to be a particular thing. And it's going to have a method called find. And it's going to take an int ID. So we're just going to say that what we should be able to find any specific user or anything that inherits from this thing, and it should return it given an ID of an int. So in our database, it will be an int, an integer or a long, whatever you want. We could change it to long and make it big int, but for this purpose, we won't. Now, also in domain, we must make our models and our entities. So let me create a new folder. I'm going to call it entities. And I don't believe in allowing the user of the domain which is going to be the infrastructure from returning any of the entities. It handles entities at the lowest level, but other than that, it won't. So what we're going to do is we're going to create a models folder. And these models are basically just going to be serialized classes. So these classes are serializable and therefore can be shown on a web page or whatever. So let us call this user model. We're just going to do the users. Alright. Public string username. Standard username. Get set public string password. Get set public. What else would we like to use? Of course, it's got an ID, int ID, capital. And finally, public. We'll give him public bool is active. So, is active. And we'll go ahead and throw in public string email, because basically this is your standard user. Okay, and we're going to go ahead and we're going to mark it with a data contract. We should be able to I'll take the easy way out because I don't go ahead and mark it as serializable, but normally you would use data contract because it's newer, and you would put data member on each of those particular attributes of the class or properties. So we got a user model. Now we need a user entity. And the user entity basically has all the properties here, but it's going to have even more. But we're going to keep it hidden, so we're never going to print it out. We're never going to give the higher levels of the domain access to it. So public date, time, birthday, for the hell of it, birth date. And we're not going to give that information to the user. We're not going to do anything with it. Although you might think, well, why not? And the answer is, we'll choose. Because perhaps it's optional, and perhaps we'll just make this optional. So, there's that. And we'll go ahead and add another one. Public validate self. So it knows how to validate itself. Assert. Well, let's just say if username double equals null or password if string dot is null or empty, or string dot is null or empty, or is null or empty email. And we would also do a regex check on the email, but we're not going to do regexes today. Then return false. Otherwise, we're going to go ahead and return true. We're not going to make birthday required, and we're not going to. So it's a valid entity. So, and notice how like that's how it is. So now we got model, we got a user model, and we got a user entity. We're going to go ahead and say user model. The user repository should be able to add. It should get a list of user model. Get users in count. We're going to say using system dot collections dot generic. How's that for you, buddy? And we're going to go ahead and create a void add user. Add user model. U. And then void make active. Active bool is active. So those are our three methods there. And of course we want to be able to find by ID, so let's go ahead and inherit from the generic repository, and we're going to go ahead and use the user entity right there. So now we have everything we need here. Let's go ahead and create our iUnit of work. So now we're going to go ahead and iUnit of work. So the purpose of the iUnit of work is it's going to be an interface. And it's going to have void save, which is what we would do if we had it in the if we had basically database calls. What I'm going to be doing is using collections, so it's going to be statically derived and it won't come from any connection in the database. But you could just use the entity framework, you could just use nhibernate or LLBLgen, and they would all just use DB sets and use different querying languages therein, or just use ADO.NET. But right now, what we need is void save and iUser repository user repo, and it is a property get and set for testing purposes. We have a set for testing purposes only. Now we'll go to infrastructure, and we're going to go ahead and add a new folder, and we're going to call it repositories. And as you might already know, if you know about this pattern, now you have to list unit of works, and this is rename rename this folder unit of works. So this is going to have, we're going to go ahead and create a new repository called the generic repository. And what it's going to be is of type, it's going to be a generic, so therefore it must take type E, inherits from generic repository of type E, and now we need to do public E find int ID. So if type of E double equals, and you can imagine it being a little more classy with reflection or whatever, but I'm just going to use simple reflection. I'm not going to go into tools and things that could do it for me. I'm not going to add any of that. Besides which, I'm not in Visual Studio, so I'm not full. I don't have a full grasp of Xamarin Studio Community Edition. But here we go. Type of E. If that double equals type of user entity. I'm going to create a list. If I can go ahead and using system.collections.generic. I'm going to do a list of users. Oh, that's super. List of user model, user entity. And I'm going to do user db set is equal to a new, and for our sake we're going to say that it has ID equal to 1, birthday equal to date time dot now dot add years -40. Then we're going to go ahead and set the email equal to software design patterns 101 at gmail.com. And we're going to go ahead and we're going to set the password equal to haberdasher. How about that, haberdasher? You got to be a haberdasher. Username code monkey. And finally, is active equals true. Okay, and we're going to go ahead and create another one, and there's going to be two here to start with, but we'll be adding more. And he's not active, and his username is um, uh, uh, black girls are awesome. How about that? Password is Jesus is God. How about that? And the email address is uh, biggest dickus. If you remember that, and I'm going to go ahead and change this to 25. So he's 25 years old. All right, now I'm going to go ahead and return user db set dot single. Let's see if Xamarin is nice enough to include system.link. Okay, it is. It has its own version of system.link. You're going to use single, okay? ID equals ID. And yes, we have to cast it to E for our own special purposes. It's not working. Why are you not working? Cannot. Well, Scooby-Doo. Suffice to say, this works in Visual Studio, but I guess it doesn't work here. This is a conundrum. You know what? I'm not going to get into it with this thing. For whatever reason, the implementation given is not, doing what it's supposed to do. So I'm going to go back to our generic repository, and you know what? I'm going to return an object, and that's about it. So anyway, I'm going to go back here, and I'm going to go and add a new file, and I'm going to go ahead and call it user repository. User repository, how'd you like that? User repository inherits from unit of, not unit of work. I user repository, but it also inherits from generic repository, not generic repository. So yeah. So I don't know why it's complaining. Oh yeah, generic required user entity. Okay, so now we're gonna go ahead and implement public list of all the things from here. So let's grab it. Let's grab this list. Now some of you might be thinking, why doesn't he do IEnumerable? Well, there's a reason for that. And that is when you do things over a wire, like WCF, what ends up happening is that you're actually gonna get that whole not known error when it's serialized across the wire. I like to make my code as what am I trying to say? I like to make my code as flawless as possible and as reusable as possible. So if you ever had to put it across a web service, for example, I am going to sort this because it's kind of rare for it not needing to be sorted. I'm going to go ahead and sort by username. Now I'm going to go ahead and implement this. What was it? Oh. Now I'm going to go ahead and select a new user model. Now, if I was doing this in real life, I wouldn't be doing this. I'd actually be using something like AutoMapper that does this for me. ID is equal to x.id. Email is equal to x.email. Active is equal to x.active. Password is equal to password. And finally, username is equal to x.username. And now it's happy. It should be happy. And it isn't because we're not including system.collections.generic. So now it is. Let's go ahead and do the add. Gonna go ahead and do base.ubset.add new user entity ID is equal to u dot ID, or I'm going to do this, int max ID, which is what you have to do if you're not pulling it from the database and then there's no auto increment, is equal to user dbset dot should be max here. x dot select x, come on, dot id +1. So this is gonna this actually wouldn't work. Calling max on an empty set I do not believe will work, but because we already have 2 in the database, it should do just fine. So we're going to do id is equal to max id. Now we're going to do email is equal to u.email. Usually we'd validate everything here. It's true. Password equals u.password. Username is equal to u.username. And so on and so on, and birthday is not in this, so what we're going to do is just give them a random birthday. Now birthday's nullable, isn't it? We'll just call it null. And finally, this one, public. And I just realized that there's no way to link the two without the ID. So let's give the int ID to this bad boy. ID, let's go back to the user repository, and we'll go ahead and do int ID. And let's go ahead and do var u is equal to user dbset dot single or default x dot id is equal to id if u not equal to null, then u dot is then u dot, okay, whatever. I'm not going to go through how this works. It's probably this. It's probably this. Double equals. Got the double equals dot. Oh, I got rid of the var, so u dot is active is equal to is active. How'd you like that? And then I'm gonna go ahead. I am going to go ahead and then turn. So there you go. And that'll be all that I have to do there. That's basically a repository. And now I'm going to do the unit of work, and we'll be cooking with gas. I'm going to go ahead and rename that file to unit of work. And I'm going to rename it here to unit of work, if I can spell it. And I'm going to rename this to unit of work. Unit. And I'm going to go ahead and inherit from iUnit of work. And I'm going to go ahead and create a property here of user repository, user repo, and I'm going to go ahead and say get and set. And I'm going to create my own little private instance of it here. Private iUser repository user repo. And here it is. User repo is equal to value. Cool. And then I'm going to return And this is where it gets really fun. User repo, question. User repo is equal to a new user repository. Yep. And basically the unit of work will take a string, con string, usually. And finally, now that's all wrapped up, we have a core, and we're going to go ahead and go to the core. And the core contains, for our set of purposes, contracts for the business logic. So, basically, we're going to go out there and do what we got to do. So now I'm going to go to, first I'm going to add this to the thing. I'm going to go ahead and say, I'm going to go ahead and say, I'm going to grab this. We're just going to grab this out of there. That was valid, but and we're going to do entity dot validate. So if not, entity dot validate return. So we have to do that. I just remembered that. Here in the business logic section, we're going to create for ourselves an empty class called, well, it's going to be an interface, user business logic. And it's an interface. So we get rid of the constructor. And it's going to have void add. It's going to be void. We'll get list of user model get users alphabetic get users who are active. How's that? Who are active in count. And we'll go ahead and import the necessary files here again using system.collections.generic, and we'll go ahead and do void add user, and that'll be a user model u, and we'll go ahead and create for ourselves a bunch of other things. Let's, find user. What would we do? What could we do? We could find a user model. Find by username. How's that? No, maybe not. We won't do this one. We'll just implement 2 for now, just to show you how things are going. Now that that contract's been written, let's create the implementation class of this particular thing, and that is user business logic. Create new. Let's go ahead and inherit from u business logic, and let's go ahead and do private unit of work unit of work. And let's go ahead and instantiate that unit of work with a new unit of work. It takes a string, but for now we're just going to pass in null. Now it should complain that we have a bunch of methods that we haven't defined. Let's therefore define them. Some of these methods are going to be extremely easy, like this one, for example, where it's just going to sync through the phone line here. It's just going to go out and, pass directly to the repository layer. So let's go ahead and do this one first. Unit of work dot user repo dot add, and it takes a user model. How convenient. And there it is. After that, we'll go ahead and return user user repo dot get users int dot max value dot what, and we'll go ahead and import from here. We'll get using system dot collections dot generic and using system dot link. So you'll get a few where I'm going to go ahead and say where arg. I don't like this arg. I like x. X dot is active. Is active. Dot take count and dot to list. And there's a way to circumstance it. Yes, I could have passed in, that count, but this is a way around that without having to write multiple methods. So there you go. This is basically domain-driven design in repositories. I hope this helps you in your career or whatever you're doing with software. Thank you.